We are now going to learn a method for finding derivatives of implicit functions. Implicit differentiation is the technique that we're going to use to find the derivative of an implicit function that is defined by the relation capital F of x comma y is equal to 0. When we use implicit differentiation, we are going to be given the function capital F of x comma y is equal to 0, or this function may look like capital F of xy is equal to a constant, or capital F1 of xy is equal to capital F2 of x comma y. No matter what format we're given, our job is going to be to find the derivative dy dx. I have written down 3 steps that we can follow whenever you have to use implicit differentiation. The first step is just to differentiate both sides of the equation. Let's highlight both sides of the equation with respect to x. And then the second step is you're going to group terms with dy dx on one side and then put everything else on the other side. And then the third step is that you just have to solve for dy dx. In this green box, I have listed what I think is one of the biggest stumbling blocks for students when you do implicit differentiation. One of the key things to remember is that if you have a function y of x and you take the derivative, it is dy dx. That part seems pretty straightforward. Let's now look at the function y squared of x. When you take the derivative, you are going to get 2y, and then you're going to have to multiply that by dy dx because y is a function of x. And then the same thing happens for any power of y. Your derivative is going to be n times y to the n minus 1 times that dy dx. So just remember to multiply by dy dx whenever you differentiate a power of y. Let's now walk through an example so that you can see how the 3 steps that I've outlined above actually work in practice. We are given the equation x squared plus y squared is equal to 25. That's just a circle centered at the origin with radius 5. And we want to find dy dx. The first step is to take the derivative with respect to x of both sides of our equation. So we're going to take d dx of x squared plus y squared, that's the left side, is equal to the derivative with respect to x of the right side, which is 25. Now we go ahead and take the derivative. The derivative of x squared is just 2x, and then the derivative of y squared is 2y, and then here comes that dy dx that we have to multiply by. And then on the right side, we have the derivative of a constant, which is 0. Our second step is we are going to put dy dx on one side and everything else on the other side. So we have 2y dy dx here on the left, and we're going to move the 2x to the right, and that is a minus 2x. Now our third step is to just isolate dy dx on our left-hand side. We have dy dx, and we're going to divide both sides by 2y, so this is minus 2x divided by 2y, and then the 2's cancel, and we're left with an answer of minus x divided by y. And that's our derivative.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.